Okay, folks, welcome back. Trigonometry, angles and ratios, lesson 6, the unit circle. So now we are going to take these triangles, which we developed our exact value ratios for, and we are going to use all of that information and go all the way around the unit circle. So one full 360-degree turn. Now, we can use the information from these triangles to fill in coordinate points on a unit circle. Okay, so below, it says in the diagram below, these three triangles have been placed in quadrant 1 on the Cartesian plane. So you can see the three triangles, 1, 2, 3. Right? So we basically just need to transpose the information that we got from those triangles onto this circle. So if we fill in all of our blanks, our 45-degree triangle had a length or an x value of square root 2 over 2, and our 60-degree triangle is 1 over 2. So down here, this is going to be root 3 over 2, and sorry, not root 3 over 2, root 2 over 2, root 2 over 2. And this was root 3 over 2. And our y values somewhat accordingly. 1/2 root 2 over 2, 1/2 root 2 over 2, root 3 over 3 over 2. Now that we know our x and y's, we can figure out coordinate points. Well, the coordinate point of this line here, this line here is going to be 1 and 0. This point here, x of 1 and a y of 0. It doesn't go up or down. This coordinate point would be root 3 over 2 and 1/2. This would be root 2 over 2, root 2 over 2. And this would be 1/2 and root 3 over 2. This would be 1, 0. Now, just like we did in a previous unit, we can reflect these over the y-axis. So flip them over to here. We can reflect them over the x-axis, flip them over to here. Then we can reflect them over the x-axis and then the y-axis to get them into quadrant 3, which is exactly what is done on the next page. But before we get there, let's answer these questions. Write the lengths of the horizontal and vertical line segments, which we just did. Write the coordinate points of the 5 points we just did. How do the coordinates of the points relate to the measure of the rotation angle? The coordinate points relate to the measure of the rotation angle by each coordinate point we know is always x, y. But when we look closer to that, we know that x is equal to cosine theta. X is equal to cosine theta. And y is equal to sine theta. And we know that because r is equal to 1. So for an example, let's go back up here. For our 30-degree angle, I know that sine is y over r, which is 1/2 over 1. This is our y coordinate of our vertex in our 30-degree triangle. Okay. Over the page. So now you can see that this has just been reflected over the x and y axes to give us coordinate points all the way around the unit circle. So we can use this also now as a tool to determine exact values for the trig ratios for these special angles. So we know that sine theta is y over r, cosine theta is x over r, tangent is y over x. We don't need to worry about cotangent and cosecant and the inverse functions of sine and cosine. So in a unit circle where r is 1, I know that sine theta is y over r, y over r, which is just y over 1, which is just y. Cosine theta is x over r, which is x over 1, which is just x. Every point on the unit circle has coordinates x and y, which can also be written as cosine theta, sine theta. Cosine is x, sine is y. So it's another way to write it. Tangent is sine over cosine, or y over x. Okay. So those are just some extra little things that we're probably going to use as a tool for us later. Now we're going to have to flip back to this unit circle. So you might want to keep your finger on that page as we answer the rest of the questions. Example number 1. Use the unit circle to find an exact value of trig ratios for the rotation angle of 240 degrees. Give each answer with a rational denominator, okay, which we always do anyway. Okay? Sine of 240 degrees. So I can quickly flip back to my circle, 240 degrees. And I know that sine is my y value. So this is negative root 3 over 2. Negative root 3 over 2. But of course, you need to have that unit circle handy and or memorized, right? So that's where knowing the exact value table will also come in handy. So essentially, these are two separate tools that you can use. And to me, it doesn't matter which one you use. Okay. Cosine 240 degrees, I know is the x value. X value of 240 degrees is negative 1 over 2. Negative 1 over 2. And if I know both my x and my y, or my sine over my cosine, I can just do my tangent. Tangent is sine over cosine, or y over x, which is going to be negative root 3 over 2, all over 1 over 2, which is negative root 3 over 2. That's supposed to be a negative sign. Divided by negative 1 over 2, which is negative root 3 over 2 times 2 over 1 negative. Negative, negative is positive. 2 and 2 cancels. That just leaves me with square root 3. Okay. Which we can confirm the tangent of 240 degrees, 240 degrees is here. This would be a reference angle of 180, 240 minus 180 is 60 degrees, 60 degrees. If I go way back to my table, I want the tangent of 60 degrees. That's how to do this easier. Way back to my table in lesson 5. What did we say? The tangent of 60 degrees? Tangent of 60 degrees, square root 3. Square root 3, right? So now if we go back, square root 3, keeping in mind what we had, square root 3, square root 3, square root 3, square root 3. Where are we? Somewhere in around here. Look, square root 3, right? But let's make sure we're in the right sign. C-A-S-T, positive, yes, square root 3. There we go, okay? So two different tools give you the exact same answers, right? Example 2, use the unit circle to find the exact value of cosine 135 degrees. So again, I'm going to flip back to my circle. I'm going to find 135 degrees. And I know that cosine is sine, or is x or y? Is x. Negative root 2 over 2. Negative root 2 over 2. Negative square root 2 over 2. Easy as that, but you have to know what that table is. Tangent of 120. Tangent of 120 is y over x. Let's go back to my table, or not my table, my circle. Find 120 degrees. Y over x. So root 3 over 2 over negative 1/2. Go back to do my work. Square root 3 over 2 all over negative 1 over 2. It's going to be equal to square root 3 over 2 divided by negative 1 over 2, which is square root 3 over 2 times negative 2 over 1. 2's cancel. Negative square root 3. Boom. And again, we could quickly double check. Tangent of 120. 120 is in here. Tangent of 120. 120 is right there, which is going to give us a 60-degree reference angle in quadrant 2, C, C-A-S-T, so it should be tangent, which is negative, so it's going to be negative something. And I go back to my table. If I go all the way back to my table, I'll see that the tangent of 60 degrees, let's see if I can do that a little bit easier. Tangent of 60 degrees, where's my table? My table is right there. Tangent 60 degrees, square root 3. So back. Square root 3. See, so you can use both to get to the same place. Sine of 180 degrees. Sine is y value of 180 degrees using my unit circle. 180 degrees, y value, 0. 0. Tangent of 270. Tangent is y over x. 270, which is negative 1 over 0. Well, you can't divide by 0, so this has to be undefined. Right. Question 3, example 3. A is negative root 2 over 2, root 2 over 2, and B is negative 1/2, negative root 3 over 2. The 2 points are on the unit circle. If an object rotates counterclockwise from point A to point B, through what angle has it rotated? Well, let's go back to our unit circle. We have to find these 2 points. Let me erase some stuff here. Find those 2 points. Our first one is negative root 2 over 2 and root 2 over 2. That is right here. And our other one is negative 1/2 negative root 3 over 2. Negative 1/2 negative root 3 over 2 is right here. If an object rotates counterclockwise from A to B, through what angle has it rotated? How many degrees has it gone if it goes from there to here? Well, I know this is 45 degrees. And I know this is 60 degrees. 45 plus 60, 105 degrees. Or you could think, well, this is 235. This is 240. 240 take away 135 is 105. 2 ways to think about it. 240 minus 135 is equal to 105 degrees. Question 4. Use a calculator to determine to 4 decimal places the coordinates of a point on the unit circle that corresponds to a rotation angle of 148 degrees. So to get those coordinates, I need to have an x and I need to have a y, which I know is sine theta, cosine theta, which I now also know is sine 148 and cosine 148. And I simply plunk those into my calculator to get my 2 values, negative 0.8480 and 0.5299. So I could plot both of those points, or plot that point using those coordinates. And then you can do the reverse. You can work backwards. The point T, negative 0.8829 and 0.4695 lie on the unit circle. Determine the value of theta, where theta is the angle made by the positive x-axis and the line passing through T. It's just telling you that it's in standard position, basically. So I know that. This is a coordinate point, and you know what I realized? I realized that I made this error back here in this question. This isn't sine and cosine, this is backwards. Hopefully you're screaming at me. Somebody's screaming at me. This is cosine, because sine is y value. Sine, cosine, nope, sine. My numbers are right because I looked at my answer, but this is written wrong. It should be cosine theta, sine theta, which means this is cosine theta, sine theta, which means it's cosine theta is equal to negative 0.8829, which means theta is equal to our reference angle would be cosine minus 1, 0.8829, and sine theta, just to make sure, 0.4695. Theta is equal to sine minus 1, 0.4695. And those should work out to both being the exact same value. Doubly checking on my calculator. Second function cosine 28 degrees. Second function sine 0.4695, also 28 degrees. So there's my reference angle of 28 degrees. But this coordinate point is going to tell us what quadrant we're in. Quadrant negative, positive, we're in here somewhere. Reference angle of 28 degrees. What's my rotation angle? 180 minus 28, 152, 152 degrees. Okay, so using our unit circle and using our table are two different methods that we can use to find exact value for our trig ratios. Okay, obviously, except for question examples 4 and 5, they're not exact values, but we can use them. Okay. And then, of course, it wouldn't be math if we didn't make it a little bit more complex. Example 6, use the chart or the unit circle to find the exact value of cosine 300 plus sine of 330. So I have my unit circle in front of me, so I think I'm going to try and use that. Your choice, though. So I'm not going to flip back and forth. It's getting a little painful. Cosine of 300. Cosine is our x value. 300 degrees is 1 over 2. Sine of 330 is our y value, is negative 1 over 2. And if I add those two together, well, clearly that comes up to 0. And then I go on to question B. Sine squared of 225 and cosine squared of 225. Well, we find 225 on our unit circle. 225 is right there. And if I'm going to square, it's negative root 2 over 2 squared plus negative root 2 over 2 squared is root 4 over 2, root 4 over 4 plus root 4 over 4, which is 2 over 4 plus 2 over 4, which is 4 over 4, which is 1. And then question C. 2 times the tangent of 150 divided by 1 minus tan squared 150. Well, tangent 150, 150, 150. We're going to have to do a bit of side work here. Here's 150. Negative root 3 over 2 and 1 over 2. Tangent is sine over cosine, or y over x, which is 1 over 2 over negative 3 over root 3 over 2, which is 1 over 2 divided by negative root 3 over 2, which is 1 over 2 times 2 over negative root 3. These will cancel. 1 over negative root 3. Got to rationalize. Negative root 3 over 3. Whew, that's tangent of 150. That's a bit of work there to get there. So now we put that in here. Oh, sorry for this side noise. I'm switching my page. Now I'm going to go 2 times negative root 3 over 3 divided by 1 minus negative root 3 over 3 squared, which is going to be negative 2 root 3 over 3 divided by 1 minus square root 9 over 9, which is 3 over 9. Here, we'll do all the steps. Negative 2 square root 3 over 3 over 1 minus 3 over 9, which is 1 over 3. I'm going to simplify that now, 1 over 3. 1 minus 1 over 3 is 2 over 3. So this is negative 2 root 3 over 3 divided by 2 over 3. This reduces or simplifies. 1 minus root 3, 1 minus 1/3 is 2/3. So I'm going to flip and multiply. Negative 2 root 3 over 3 times 3 over 2. Cancel, 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 cancel. Negative square root 3. Boom. Done. That brings us to the end of lesson 6, which actually brings us to the end of the unit. So we'll be testing shortly and yeah, checking Stellantis for questions or the sideboard or wherever they happen to get posted in calendar or something. And we'll see you next time.